everybody. Today's lecture is Mathematics Grade 10, Lecture 5. Graph quadratic relation if the relation is given in the factored form. So the first method is to use x and y intercepts to graph the relation. So step 1 is to find the x-intercepts. To find the x-intercepts, you let y equals 0. You let y equals 0. So this relation equals 0, which means one of the brackets must be 0. Otherwise, the whole thing cannot be 0. So this equals 0 means this is 0. X minus r is 0, which means x equals r. So r is an x-intercept. Or this part can be 0. So x minus s equals 0. That means x equals s. So s is another x-intercept. We have two x-intercepts, r and s. The next is to find y-intercept. To find y-intercept, you let x equals 0. So in here, x is 0. And this x is also 0. Therefore, your y equals a multiply negative r multiply negative s. Y equals a multiply negative r times negative s. So it's equal to ARS. This is a y-intercept. Once you have x-intercepts and y-intercept, you can graph the relation. Let's have an example. Okay, let me erase this. Example. Y equals this is y example. So follow the steps, find the x-intercepts, and then find the y-intercept, and then graph. So x-intercepts is this equal to 0, x equals negative 3. Or this is equal to 0, so x equal to 1. So I have two x-intercepts. Y-intercept you let x equal 0, x equals 0, so y is equal to 3 times -1 is -3. I have x-intercepts and y-intercept. Then I can graph. X-intercepts -3, 1. Y-intercept -3. So my graph must pass through this point, and this point. The quadratic relation means it's a parabola. So I draw a parabola passing through these 3 points. That's it. That's my graph. It's only a rough sketch passing through 3 points. The second method is to find the x-intercepts and the vertex. So let's use the same example. So the second method. Method number 2. So the first step is find x-intercepts. For this example, we already had x-intercepts, which are -3 and 1. But the second step is not to find the y-intercept. Find the vertex. The vertex must be between the two x-intercepts. It's not only between, it is in the midway. Look. The vertex has to be midway between -3 and 1. So, x-coordinate of vertex is the midway between this and that. So we see the x-coordinate of the vertex is -1. Once I have the x coordinate, I can find the y coordinate of the vertex. Number 3, find the y coordinate of the vertex. Because I know the x coordinate is -1, I put -1 here, -1 here, and I get y coordinate. So the y coordinate is 2 times -2 is -4. Therefore, vertex is -1, -4. Once I have the vertex, then I can graph now. So the next step, now you can graph. Because I have the vertex, so I can graph it more accurately using the odd numbers. One, 3, 5, 7, and so forth. Let's see how we do that. Okay, let me draw this using as a 1, 2, 3, 4 scale. Okay. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. The vertex is -1, -4. -1, -4. 1, 2, 3, 4. So -1, -4 is here. Look here, our relation. Okay, remember our relation is our relation is this, right? So here is the general expression. I use a, but in this example, a is 1. So this is easier to graph because I now use 1, 3, 5, 7. If a is 2, I need to multiply all these odd numbers by 2. So let's do a equals 1. Let's graph it. So I go to the right. I don't know whether I am on your way. So this one step to the right and one step up. One step to the right and 3 steps up. One step to the right and 3 steps up. 1, 2, 3. Actually, this is my x-intercept. One step to the right and 5 steps up. 1, 2, 3, 4, 5. Because the parabola, the graph of parabola is symmetric with respect to the midline, with respect to the axis of symmetry. So I can get other points on the other side just by symmetry. So I have this point, and I have this point, and I have this point. Now I can draw the graph. That's it. That's my graph. So you see, the second method, starting from vertex, I can get more points just by using 1, 3, 5, 7, and so on. If that is a is equal to 1, if a is equal to something else, you just multiply the odd numbers by the value of a, and this is how many steps you go up. So this is how you graph. Before I conclude my today's lecture, let me give you a challenge question. What is the question? Y equals so how do we graph this? First of all, this is not a quadratic relation. So you do not expect to have a parabola. But we can still use method 1, which means find the x-intercepts and find the y-intercept, and you just draw roughly. Okay. So x-intercept, two, right? Because x equals 2 makes the whole thing 0, makes the y 0. 5. X equals 5 makes y 0. And 7. When x is 7, makes y 0. So 2, 5, 7 are x-intercepts. So how about y-intercept? Y-intercept is to let x equals 0. So y-intercept is -2 times -5 times -7. This gives you -70. So y-intercept is -70. So I use intercepts to graph this. X-intercept 257. Okay, 257. Y-intercept -70. Okay, suppose this is -70. So your graph must pass through the 3 x-intercepts and this 1 y-intercept. How do you do that? You remember, you must pass through these 4 points. So let's start from here. Because you have to pass through this point and this point. So your graph looks like something but you cannot go up indefinitely. It has to pass through this point. So you have to bend it. But you cannot go down forever. You have to pass through this point. So you have to bend it up. Do you need to bend it again? No, because these are the only 3 x-intercepts and you have no more x-intercepts. So it goes up forever. That is your graph. And if you are familiar with polynomial graph, look. This is degree 3. This polynomial, if you expand it, the degree is 3. Degree means the highest exponent. The highest exponent is 3. X times x times x is x to the exponent 3. If a polynomial has degree 3, you bend it 3 times. 1, 2, 3. That's it. Let me say it again. 1, 2, 3. Can you generalize this idea? If your polynomial is degree 4, then your graph looks like 1, 2, 3, 4. Understand? But this is challenge. This is not in the quadratic graph. Okay? So, that's today's lecture. Do you follow? I hope you do. Goodbye. See you next lesson.